welcome to the Fleet live stream. It's another exciting Fleet Friday. Hope it's treating you well so far. We're going to explore more about the data that you've been gathering. It's going to be a good start with all the tests, and then we're going to set up for a new competition on the search and rescue mission in the sunny conditions, and we'll walk through that right at the very end. So, if this is your first time to Fleet, you get two options right off the bat. You can choose to quick play or dive right into a mission. Quick play, you have no budgets. You can spend all the money you want. Definitely sounds pretty awesome. Mission headquarters is where you can set high scores, though, right? So let's start in quick play, but then work up to mission headquarters. You can see in my display that I am showing off a couple web pages. So, first, a hearty congratulations to all the PEP. We have a promoting electric propulsion competition where college students are designing, building ships and that are purely powered by batteries for a 5 mile race. So, two teams presented their work this Tuesday, early in the morning, 8:20. It's when the good engineers are working hard, and did some great work showing off how they designed the electric engine and all the battery packs, and then also the hull design. But we are going to be using. Oh, and if you need to, you can come to Fleet. FleetEngineer.org will redirect you to this page. You can download Fleet. You can do all kinds of exciting things with Fleet. This is where we are. We're on the live stream. And then if the Fleet discussion is always available the rest of the day for us to talk about questions. Alrighty. Without further ado, we're going to do some data checking today. So we're going to really document what is going into our ship. We're going to record the speeds that we're attaining. And we're going to try and make the fastest ship possible for the next bit. So let's do that. Alright, so this is not the ship that we need for this mission. This ship's too small. So I'm going to get rid of the entire ship by hitting this trash can button. And then there's one clear button on this screen that means add. Add. And then if you're familiar with how computer games are designed, we're going to go with this hull form because it's the best one for the search and rescue mission. This is set up like a parented list. So now that I chose a hull, and right now I'm using the right click button, so I'm holding down the right side of my mouse and moving it around, and that's what's given me the ability to oh no, I'm streaming but I lost my feed, I think. Okay, we're back up. Maybe it was a temporary glitch. So if we lost anything, I went up to add and I added in a hull. Now we're going to add in other components. This is our checklist. So now that we have the basic ship design, we can add in our propellers, what spins and makes the ship go forward, the engine, what spins the propellers, the rudders, what directs the force so that we can turn, and then the deckhouse has all of our components and where it has all the steering wheels, all the mechanical, all the engine. All the the computers, and this is where also the crew will be. And then we'll talk about weight in a little bit. Displacement and weight are going to be synonymous for us. So let us use the checklist. So we don't see propellers in this menu, but there's a few menus here. So let's add a propeller. So we have a baseline model, and then we also have a high efficiency model, where efficiency means the ability to do things, more things with less. It's good to be efficient. Got to be efficient with time. We're going to be efficient on the water. Now we're going to add in an engine. We have medium speed diesel that costs $500,000. You can see that cost is right in the bottom there on the left, and it also weighs 100,000. The turbocharged diesel weighs 70,000 kilograms less. It only weighs 30,000 kilograms, but it costs $100,000 more. We're going to use it right off the bat. We got all the money in the world to spend, so why would we not spend it? So this is half of a ship. It's not the full ship. We can't put the engine up here because the propeller would be too long. And you probably have seen boats where the engine and the propeller are on the back, but this engine weighs too much to do that. So we got to put it in the middle, which is right where I placed it. So let us. Good morning. Good morning. It's good to see people on here this morning. we are going to add in a rudder now. And let us go to plus. It's under propulsion. It's a structure, and it's right here. And so now we'll see. This costs $10,000. This one costs $10,000. This one costs $10,000. So we can't save money, but we can make it for the. We can choose the one that's best for what we're trying to do. What we're trying to do right now is go fast. So drag is what slows us down. So having low drag, having less drag sounds great. We could also be able to turn better, or we could have a balanced situation. But let us do some low drag. All right, and now we got to add the deck house, and we can switch this up. But it's under superstructures is where we find our deck houses. We have one that holds 20 people, one that holds 10 people. They weigh a little bit different. There's about a 9,000 kilogram difference. There's a lot of weight in here, but they cost the same. So let's go ahead and put this one on first. And I'm going to put it right here in the middle. It's good to put the weight in the middle. So now, ooh, good looking ship. Good looking ship. We're not heavy enough, so it's kind of like a tin can on top of water. We need it to be heavier so it sits in the water, so it's safer to be on. So we have some changes to do. But before we do that, I want to get back into what we're talking about, data in engineering. So for the engine, I'm using the turbo. So I'm going to start taking notes, and then we use high efficiency. And I could even make a key. I could make a list where I just would write HE, just a few things. For the rudder, we use low drag. And then we're going to have to find our weight and our cost at the end, okay? And then we're going to test it out in the speed test and the maneuverability test. Let's even shade these columns a little differently. Let's shade them in the we're going to go fast color. That is definitely a we're going to go fast color. All right, and then what we'll do is once we get this data down, we're just going to choose one thing, but we can use the beauty of technology to copy and paste. One of the, next to having a ship that will be able to save people in a shipwreck, copy and paste, probably second best technology. So let us jump into getting this even more better. So we're going to add in more weight. And this is, so there's two parts of this that are easy to forget and will kind of make it frustrating for you in a short period of time. One, we already did. The engine can't go on the back, can't go on the very back. So what I did is I clicked the ship button to see what's on my ship, and I found my engine component, and I could get rid of it if I want to, but what I want to do is pick up and move the item. So instead, we're going to be able to move it around now, and you can see it's right behind. You can actually see it right here, right? Woo! But I need to put it here so I can't actually see it. All right, so that's number one. Number two, there's ballast tanks on ships. And so you can kind of see what it looks like as this rotates around. It's compartments that we store water in that are around the bottom of the hull. And so the cheapest thing on the ocean is ocean. So we need to add 60,000 kilograms of something. So imagine if we wanted to use gold. This ship would be worth trillions of dollars. But because we're just going to put water in it, these are going to cost us $500 to put into the boat. And then the ocean is going to cost us about a big $0. So this is a great, efficient solution to the problem of making a ship that can have the appropriate weight, so it's as safe as possible for heavy seas conditions. We're not going to have that too much this week, but we will soon. So it's good that we're keeping an eye on it. So you can see there's containers in the middle, and those are the ones I like to fill up first. But we can test, we probably won't have time to test it out today. But you can certainly explore what happens if you fill up just the left side, or maybe you do the left and right and leave the middle empty. There's a lot of opportunities here to explore and check out what data makes the most sense. So if you were doing that, you might explain how you distribute the weight in your columns here, right? So there's a lot of different ways to check to track this data depending on what you're exploring. So this is kind of, we're using the engineering design process to focus on data right now. So our mission is the search and rescue, and we'll go into that a little bit later. We are imagining a solution, that's what we're doing right now, and we're building the prototype. I'm setting us up to do a ton of data collection so that we can ask questions more about how to improve our speed. Okay? That also involves the scientific method. So we're identifying one variable that we want to modify. We're going to make some hypotheses about what's going to make us go faster, and then we're going to collect data to see if we're true. So that was a lot of talking. We got ballast tanks in here. We need to fill them with water. The yellow box is around this one. If I click this one, the yellow box is around this one. If you look in the background, you can see that the yellow box is right here. And we are just going to fill it up with water by doing this. It says done, and it's so enticing to click done. But you don't need to click done. Don't click done until you're actually complete. Just keep clicking new boxes, filling them up with water, and you'll see as I do this one, watch the displacement. It's increasing. And so our weight's called displacement because the amount of weight that the ship's weight is equal to the amount of water it displaces. So the weight of the water that moves away because the ship's there is equal to the weight of the ship. So the weight of the ship and the displacement are equal quantities. They're equal weights. And we're measuring them in kilograms. All right, so we're getting close. And so I'm looking to see when this red X turns green, because with ships, it's not like we need to have it down to the exact kilogram. There's some tolerance, and there's some reasons to make it lower or higher. We'll go low the first time, then we'll max out the weight the next time. So that's 94%. I am trying to keep it balanced. You can study what happens if you change it so it's not balanced. And some of my sea cadets and my sea perch teams, they will probably have some good experience and some good knowledge already here. All right, so displacement 427,577 kilograms. 427,000, comma. Look at that, good comma in there. 577. I'll even put in the 0.3. All right, so we got the weight, and we are done now. It's not showing us the cost, but that's going to come into play a little bit later. Okay, so I'm going to write not recorded here, but we will explore that later, and we can actually talk about how to gather data about certain design elements. Alrighty, so I think we're ready. So what we did is we added things by hitting the plus sign. There's some cool things that we still need to explore later on, but we don't know why we would need them yet. If we need to see what's already on our ship, we can click the boat button. We can also name it the best boat ever, right? And then this also is a lot of information that you would learn if you're a freshman year college student studying naval engineering, naval architecture, and we can go into this another week. But this is a full simulator, it gives you real access to how engineers work to design these ships. These dots that you're seeing, they each have a one meaning, and it's about how the force of water is pushing up the boat or the force of gravity is pushing down the boat. And you can imagine, like, if your hands are pushing on each other, you want them to push equally, otherwise they'd slip, right? And so that's a very uh, easy to understand, but probably too simple explanation for what's happening there, but it does work out. All right, so let us take this ship out by hitting play. So now I'm hitting play, the seawall's coming down, water's being piped in here to safely pick up our ship. Such a good looking ship. And now we can take it out to the ocean after we have a simulator test that's called a fixed roll position. But what's really happening is they're pushing a wave across the ship to see how sturdy it is, how much it'll rock back and forth when it's hit by a wave along the broadside. As you noticed, that was awesome. That barely moved at all. We will see some ways to make that not as effective. So we have tests that we can do to try out our boat in the quick play. We can do the speed test. We can do the maneuverability test. We will do combat practice probably next week, and we will do rescue practice later today. We don't have the required components. We're going to have to find these required components. But let us first do speed test. And we might actually repurpose our cost column. So W, alright, I'm hitting W. You can use the Minecraft keys, WSD, or just hit up if you want to make your ship go forward. It takes a long time to go fast, right? We saw that our ship weighs 427,000 kilograms, which is roughly a million pounds. And then what I just did is I clicked this button up here, which, because we're in a simulator, we can control every variable, including time. And so I'm making time go twice as fast so we can do more tests in the time we have together this morning. Alright, so we are rolling down this track. Alright, it's like a field goal or a soccer goal. We just need to get between these two buoys as quickly as possible. I actually don't have to steer that much this time. Sometimes the current makes me steer, but also this ship is really stable. So the waves, the current is not really pushing it over too much. But I want this time 1 minute 41 seconds. So I'm going to write time like this. You can write it any way you want, but I wrote it as 1 minute 41 seconds. If I want to be really specific, I could do something like 0 hours 1 minute 41 seconds. But I will be succinct. I will be straight to the point. So, if we were immediately ticked with how things were going, we should take it back to the dry dock. We can make repairs right away. But I am not that. I'm gonna explore a little bit more and try the maneuvering test. So in this test, we need to go through a course that goes like this. So I need to keep these green buoys on my left and these red buoys on my right. Again, I'm going to click this button so that we can get through more tests together. But especially in the beginning, you probably want to leave this off so you can get used to anticipating these curves. And then, as you become the fleet master doesn't need to take a minute and 41 seconds to get through the speed test. We can do it in half the time, get it done in 50 seconds, go back and do another speed test, get a lot of data. So I'm coming through the track. I try to go through it the same way every time to make it as similar a test as possible. But when we're engineering, we have real-world solutions, so we have real-world noisy data. So it's not, if I do this again, and let us try that actually, so we can talk about this part. We're going to do that one more time, exactly the same way to the best of my abilities. So I'm going to hit W right from go. I'm going to hit speed 2x. Seems like, no, it seems like the waves are a little bit different this time. A little bit more to the right than coming in from the ocean. But let's run this again, and then what you may want to do is take averages. And so if you haven't learned about an average yet, if we want to see what our real time is when we do two tests, what we'll do is write down the number in between. That's exactly in between the two numbers on the number line. And we can find that number by adding them together and then dividing by 2. So look, I got 1 minute and 20 seconds this time. So the time between 1 minute and 20 seconds and 124 seconds is, it's the minute's the same, right? So what's the number between 20 and 24? Exactly between? It's going to be 122. And then I'm going to write average of 2 tests. Alright, so we got good information here. I'm going to change this column for now. We need to think about costs later, but we're going to have to make some adjustments to this ship that we need to track. So we're reworking our data table on the fly to adjust for new data purposes. Once you get a data sheet you like, you can definitely roll with it, but don't hesitate to change what you're tracking or add what you're tracking when you find something that's necessary. Just make sure that you're only recording real data, that you're not putting in any data that you kind of remember but don't really know. All right, so we want to do search and rescue test. So we're going to first add in a cargo of rescue equipment, and then we'll put that on the back. And then to show what is the best possible solution in all the cool things, we are going to add a rescue boat. And I'm going to add the smaller one because I need to put it in the front so I can save more room under the advanced menu for helicopters. Helicopters. This game is ridiculously fun. So I added in a landing pad for a helicopter because there wasn't a helicopter to choose from. But now that I have a landing pad, now I can add a helicopter. So first you add the helo deck, and then you add in a helicopter. We're going to add in this sharp-looking helicopter. And then, so we can test lots of things at once. Let's max out our weight and see what happens when we fill our ballast tanks to the maximum allowable amount. So I clicked ship, and I went and found ballast tank, and now I'm going to click the water button, and this allows me to edit or change the amount of water that's in these tanks. So I'm going to completely fill up the last two that I kind of partially filled up. I'm going to completely fill up these in the back here. And then I only have two left that I could possibly fill up. So we'll see if we can max out the weight this way. Oh, too much. All right, so I'm going to bring it down to 478. So 75%, because I still do want to keep it balanced on either side. That's too much still. So I'm at 56%. Let's bring this down to 56%. So I'm trying to bring it down equally on both sides. So I'm 4% off, but that is close enough for me today. So now we are done. Now I can click done. So I have the maximum weight boat. So let's add in the weight. 472,000. 306.3. And I'm not going to add the weight measurement to everything, but it does annoy me not to have my units labeled. So I'm going to put kilograms in the title for that column. Now that we made changes to the ship, when we hit play again, we're going to have to do another stability test because maybe we made it so our ship isn't as stable. Because we added so much weight to the ballast, I think those are pluses, but adding this weight to the top makes it more wobbly. It really didn't move at all, but what we're trying to avoid is this idea where we have too much weight above the water and not enough weight below the water. And the more that we add to the ship, like helicopters and rescue boats, which we are going to use now. No, let's finish the test. Let's keep on objective. All right, so we're going to run these two tests the same, and then we're going to do a third test. So same strategy, right? Speed 2x, hit W right at the beginning. If you want to, some people also record maximum speed, which is pretty useful because when we get to do the shipwreck mission at the end of the hour today, you'll see it's pretty far. But that means you're at maximum speed for a long time. Whereas we get a good sense of that here, but not necessarily a perfect sense in this track, in this speed test, which is going to be a little bit around 0.5 nautical miles. And we're going to go 3 times as far, at least, to find these shipwrecks. So we're getting into our time, and because we have excellent data, we're going to see that we have, interesting, 144. Close, but slower, right? So we added weight. I'm going to use, the second best technology to copy and paste what we still are using. And let's go check out the maneuverability test. We're only going to do it once this time, but I think some of you engineers have some time and should really get used to taking the data in pairs or in triple to find the best real data, because you can see like we found that the first time we did this test was 1 minute 20, and then the next time was 1 minute 24. I just found out in the speed test that I was 3 seconds slower, but we were 4 seconds faster in the last test uh, without making any change to the ship. So unless we have like more data, it's hard to conclude that we're faster or slower with any certainty unless we really do some replication, unless we do it over and over again to check it out. Because look at this. Now I'm only 1 second faster, slower on the maneuvering test. But let us add some video game ability and start exploring what our mission's going to be. So, the objective for this mission is to rescue the 2 mariners located near the buoy. And the one thing that we'll immediately note, oh no, I clicked the wrong one. So I'm going to hit escape, and this brings up this mission. So I hit the escape button in the upper left corner, and I can either restart this mission, so if something went awry and I need to start again here, but I'm going to exit because I don't want to do that mission again. I'm going to hit play to get back to where I can test. Up here, occasionally you can escape things. I haven't made any changes to my ship, so I don't need to do the stability test again. So I need to click the rescue practice, so there's a green circle up here, and now when I hit play, I'll be able to go out and do some excellent rescue practicing. But just like I was saying before, there's a green dot right there. You may be able to see it, but what it just reminds us is that this ship is 400 feet long. And so we can save people with the ship or the rescue boat or the helicopter. So I'm going to come out here. I'm going to use all the tools. We're going to explore the button. I'm not going to set the best time on this, but we will see what's going on. So one of the hardest things about getting used to being a ship captain is that these ships, since they weigh so much, it's like an elephant. It takes a long time to get an elephant running fast, but once an elephant's running at full speed, it takes a long time to slow down. So my engines are going full reverse so that I can slow down enough to pick this person up. And once the bar goes completely green, it says, great, one more left to go, that I rescued him. And I didn't run into him. So I was right-clicking again to look around. I'm right-clicking, looking around this beautiful California scenery. And I'm going to decide to use this boat. So I clicked on the boat just with the left click. And now we're going out. And I just drive this boat just like the other one. But there's a small difference. It's tiny. It's not really that tiny. This is quite a long boat. This is a great Coast Guard vessel. However, it is a bit more challenging to drive in these seas. So it's good to get used to being able to drive with the waves. For my friends, which I assume are all of you right now, when you drive full speed, chaos will ensue. So let's do that. So I can't save them if I'm going too fast. And it tells me I need to be closer. But now that I'm going super fast, it's really hard to control this, right? And now I'm slowing down, but it's too late. So if I go full speed in this boat, it's not going to work out well for me. But let me use this as an excuse. I'm going to hit space bar. And now this brings me back to this ship, okay? So if you hit space, you can change what you're looking at and what you're doing. So I can see my little rescue boats over here hanging out by the buoy. But I'm back on the ship, and I'm going to use my helicopter. So I clicked on the helicopter. It takes off. I'm not touching a button right now. It takes off by itself. If you touch a button, you may run into your own ship. It's telling me right now I can land. And it's like, yeah, thanks. I just took off. I know I could land right away. But what I want to do is come over here and save one person in the water. All right, and so this feels like I should be able to save him right now, that I'm over top of him, but I'm not. Now I am. So he's off my screen. He's below my screen. And now I'm directly over top of him, and I can drop this rescue equipment to him. And I can't really see it because the button's in the way. But he's being saved by this rescue equipment. And now that we've saved all the people that are in the water, there's just two. I got to get back to the ship before I run out of gas, and then the mission will be done. So you can put these boats and helicopters on your ship. You click on them, and then a button pops out and you launch them. You can drive next to people with the boat or the ship and save them, or you can use the helicopter to go over top of them and drop rescue equipment and then bring them back. So let's do one more thing. Oh, I don't want to choose another mission right now. I do want to go back to the dry dock, because where do you take a sick boat? To the dock. To the dock. All right, so this is everything that's on our ship right now, right? And there's no budget, but let us get into the mission a little bit. So we're going to return to mission headquarters. That saves our ship there temporarily. We're going to choose this mission for this week. We have a $2 million budget, all right, and we're going to work with a shipwreck. So that's why we had to put the rescue equipment on our ship. But and I'm going to hit escape this time. We're not going to look at the dry dock. But now I'm $140,000 over budget. So we added in helicopter, rescue boat, rescue equipment. So let's think about how to do this. I want to keep the expensive engine, but let's look at the cost of some things. So maybe I don't want to use a boat and a helicopter. If I get rid of the helicopter, I save $350,000. If I get rid of the boat, I save $120,000. So helicopter's pretty cool. Let's get rid of this boat for a little bit and see how that affects our speed. We've got the helicopter. I'm going to need to change one more thing. So with the propellers, I don't think I can save all $20,000 with just a propeller change. So what else do I got? I've got the low drag rudder, but there's no cost saving there. Ooh, hard choices. I think I do need to get rid of the propeller. Maybe what I can do instead, though, is this helicopter is pretty sweet. But there's another helicopter that's a bit cheaper. So let us compare our two helicopters. We can spend $300,000 on the beautiful red helicopter that has room for 2 passengers in addition to a full crew. It also only goes 35 knots compared to the super speed one that we just used, 55 knots, but it costs $50,000 more. So let us use the $50,000 helicopter. And oh, whoops, that was just a complete mistake. We gotta go cheap. We gotta save money. And so now for cost, we have $29,000 extra. So we haven't changed anything too much. I'm going to copy everything here for this next round of tests. We didn't change the propeller. We got rid of the rescue boat. And the next thing that we're going to do is reduce some weight. There's one other cargo that we should talk through, though. This cargo here, pump equipment, allows us to salvage sinking ships, which sounds pretty useful right now. So I'm going to put this cargo up here. So we got this nice cargo right here. But now I don't want to keep the weights together. So I'm going to move this one. I'm just going to click right on this green box. It tells me it got the green box. So I'm moving it to the front. And sorry if I haven't mentioned this earlier, but I can rotate things with the R key. It says it right here, and I can also hit escape if I want to stop. But I rotated it so that way they would sit next to each other pretty snug. And for those of you who made sea perches before, having this weight distributed, making it equal, really nice thing. So we still have $19,000, but let's go check this out. So again, I've made some changes, so we're gonna have to do the stability test to make sure that this new design is safe. I'm gonna hit stop because I forgot to get one important piece of data. Let's actually minimize the weight and get a little bit more information about this weight distribution thing. So I'm gonna empty out these again, and we're gonna bring it down to close to 427,000 kilograms. So we emptied out this one now and this one. So we're at 441,000. Ooh, hard clicking. There we go. Oh, that's going to be too little. We need a little bit of water in here, I think, to get it so it's right around 427,000. Too little. There we go. All right, so 32 and 41. We can make it a little bit lower, I think. Oh, that's higher. There we go. 427,948. So 427,948. 0.4. Unnecessary level of precision, but we can do it. All right. So we have weights somewhat comparable to the first trial. We are done now. I clicked done. We added in rescue and pump equipment, and let us test. To be honest, I'm not as worried about the other components as far as the speed. I think that all this contributes to the weight, and that makes a difference on the speed. But I'm not as worried about what exact type of helicopter I have that will affect my speed, which is my real big concern here. But let's say you are focusing on setting the high score this week, maybe in the search and rescue mission, maybe in that competition that ends on May 22nd. Uh, and then you may want to actually track which helicopter you're using. All right, so now we have a new option here. Let's talk through this. This is the mission, okay? The search and rescue mission has objectives and budget and all this stuff. We still have the speed test, the maneuvering test, and the rescue practice. So now that we're in the mission, we can see the tests and the practices and the mission all. These are our options. We don't have anything grayed out right now because we have the required components for this one, and they don't show us anything that's not related to our mission, which is search and rescue. But we are going to need to do some testing first. You can jump in without testing, but it's not the engineer's way, right? Engineers test, study, and really think about how we can improve these designs at every step of the way. So we're not jumping right into search and rescue right now. We're going to do each of the tests. We're going to try and do them as quickly as possible. We've got a good looking ship that has some good cargo that are going to help us do all the parts of the competition. And we are motoring down the track. So again, I want to see if we are doing well speed wise, because the search and rescue mission requires a pretty far drive, like I mentioned before, and it stink to find out we had a slow ship or made a mistake in the ship construction, made it slower after going for 4 minutes out to a shipwreck. We can do a quicker test here, and check that data. So we are coming in. I think it's going to be pretty good. 140. So it's the fastest time, but in all honesty, these times aren't that different, right? I mean, we're saving a few seconds here and there, but overall, no big swings, no big problems, no big solutions that we must keep. All right, so let's go back to missions because we don't have a sick boat, so we don't need to go see the dock. We need to do some maneuvering practice. All right, so we are going down the track. It always tells us we can click up here if we need hints. It really tells you what each button does. We are simply trying to get as much data as quickly as possible. If you're in a house or a place where there's many good engineers, you can work together on this, right? So someone can be in charge of keeping the data, and then someone can use the computer. Someone can organize what we're exploring, and then like every 10 minutes you can switch roles. So you get used to how engineers have to work in a team, and it'll remind you that it's important to listen to others and work together. All right. So look at this. These times are really getting close together. We are going to do the one more practice, and then we're going to run this mission, see what we like. All right. So we have the same setup. These people are in the exact same spot. That will not be true for the mission. And so I'm going to go straight for one person, try to save that person as quickly as possible, use the helicopter to pick up the other one, and I am going to try to treat this just like I'm in the mission where I'm saving people, and that means I need to not go quite as fast so I can adjust to what's happening on my screen. Now we're getting close to this person, and once it starts saving him, I'll feel confident. Ooh, there we go. All right, I'm going to go take off in the helicopter. My ship can save him. Ship doesn't need me right now, but I need to make some time. So let us go save this human out in the water. Got him. Look at this. Look at this time. Just gotta get back to the helo deck and we are done. And this is the kind of like testing and practice that will help you get into the game, get used to how to use the tools, and then we will be able to set the high score, which is always a great goal to have. So we were able to do this in 135, 136. Really snuck in that extra second there. But let's run the mission. So the mission is search and rescue in sunny conditions. We will explore these other treacherous environments later. But let us first master the sunny conditions. So we'll see under advanced there's things like comms. We don't need extra communication because it's sunny, so everyone can see what's going on out here. West is 270 degrees. This is 300 degrees. Treat this like a number line, and you want to aim where whatever number they give you right here, that's the number you're aiming for here. You saw right away I clicked speed 2x. We do not see a shipwreck yet. We will see a shipwreck, but we got to get out there quick. So now it's saying I need to adjust my settings a little bit, that it's not 281, it's 286, because I didn't quite adjust quickly enough to where I needed to go, or maybe the current's just pushing me more than I'm noticing as I adjust the speed. You don't need to hold down the throttle, although I am a button masher and tend to, but you do need to keep moving the steering wheel to stay on course. Once we get out there, we're going to have to rescue 5 humans. We also brought that pump equipment, so we're going to try to salvage the ship. Oh, you see it? Right there, that dot. That's where we're going. That's where we got to be. It is the place to be. All right, so the ship is huge, right? We can rescue it by clicking on it, just left clicking on it. The people, we saw how to rescue them in the rescue practice. There's going to be 5 of them. It's going to give us a cut screen. It's going to give us a look around. We need to remember where all 5 people are, because the easiest way to set a terrible score is to forget someone. And you won't forget them. You have to find them. But you can definitely lose them. And then it takes a while to figure out where everyone is. So if you're working together in a team, this is definitely a spot where you both try to remember where they all are to talk and get all that information. So we got 2 here, 3 there, 4. And 5. So man, I came in. It would be great if I went right down that little middle spot. Woo! We gotta slow down. That is way too fast. And so one thing that we haven't talked about yet, but it's bad for your score, is if you run over people. So I already clicked on the boat to save the ship. I'm trying to save these people and now I'm going to launch the helicopter, and that's going to finish saving that person. I'm hoping it'll save that person, But I'm going to go out and save the furthest person right now. And come back and save the second furthest person. But I had to save money, right? Or I chose to save money on the helicopter. So I can't pick up all three of the people that are out here. So I'm going to have to take 2 trips with the helicopter um, to save everyone. And that's going to be a regretful choice. Because if I could just save the other person right now, we would be done. But I'm going to have to land and take off again. And that's a shame. Not going to be a bad time. I don't think I ran into anyone. However, I do. I really would have liked to finish under 5 minutes. Alright, so I'm saving the last person. Once I get back to the helo deck, we are done. We have salvaged the ship. We rescued 2 people with the ship, with our ship. And we rescued 3 people in 2 helicopter trips. So if we were really getting serious about taking notes and documenting how it's going, I would want to note all of that. Alright, so 2,447 points, 1 ship salvage, no collisions with people. And so if you ever want to see what the scores look like, you come into logbook, missions and achievement, search and rescue. If you're in a class like Mr. Rocky's class, you can see all of your fellow competitors, and then you can stack up against the entire fleet community. So I just did that by clicking View Leaderboard here, and you can look at the other missions to explore those leaderboards. If you want to change the weather, we don't need to this week, but you can always change the weather here. You can save ships to your account, and you can see this is the best boat ever. That's what we're working on. And it also records all the components of it. The properties, these are the information that's when we click the ship that shows us all the, and I'm right clicking now to move this around. So these are the freshman year college physics pieces. And then this shows the tests that I've done. And so the maneuvering test, that's not for this ship. It shows me my best ever. So I can keep an eye on what's the best ever I've done on these tests. So somehow we'll find some ways, but obviously there's ways to go much faster than we are. Alright, so let us go back. So I can go back to the very beginning screen or go back to the dry dock. And I can also check out my settings. So if you want to, you can change the quality of the graphics from fastest to fantastic. What a great range. Full screen, you can also just hit Control F to make it full screen. You can log out or quit, and there's a help feature right here. But we are going to go back to the dry dock. Alright, so we're going to make one change. So let us change. I'm going to go awesome helicopter, so that I had a mistake at the end, right, where I need to take 2 trips instead of 1, and that was really tough on me. But I need to save $30,000, and I can't save that by switching the propellers. But I can make one disastrous change. Maybe not. We're going to go medium speed diesel engine. And we're going to test that solution out. And then we're going to get rid of our diesel. And now when I come back in to add, it takes me right to engines because it knows I need an engine. So this engine weighs 70,000 kilograms more. I'm going to put it in the same spot, but our weight is very drastically changed. I still have an inkling, and we can talk more about why, that our boat should be light and not heavy. But let us get the weight back down to 427,000 kilograms. So this is acceptable, but I want to go light. And so I'm bringing the water out of the bow, the front of the boat, and then I'm gonna bring this down. Uh, bring this down. Maybe like 81, 80, 68. All right. So now the water's changed pretty dramatically. Before we filled up everything in the center, and once we did almost all the sides, and at least we did two or four of the side containers. But now we are done. So now I got super helicopter. I still got my cargo, and we are ready to test. All right. So we need to do one more stability test, one more speed test, one more maneuverability test, and then we will set up our final run. All right. We are ready for the ocean. We're ready for our speed test. Speed test quick, hitting W from the beginning, trying to get between these two buoys as quickly as possible. Extra data I could track looking at the high speed, maximum speed, because as you saw, it was I finished the mission in about 5 minutes and 20 seconds, something in there. But I got to the shipwreck around 3 minutes, so over half my time was just trying to go fast. So that we have never deviated, we have never changed from the low drag rudder, but you can explore that option, right? That's something that you can definitely explore. Waves seem to be pushing me around a little bit more. Maybe the ballast tanks aren't filled in the best way. And so even though we're only talking about numbers as data this week, we'll probably talk more about how to do some data collection in words. So now look at our time, 148. Marked difference. Uh, Maybe 4 seconds isn't going to be the thing that makes or breaks our score, but we are slower. We have never gone slower than 144 in all of our tests. So now we're going to do the maneuverability test. Maybe we maneuver better than we did before. Let us go explore and see. We are getting down the track. And then I am not going to do the rescue practice with this. I've practiced a lot, but you should practice if you're new to this game so that you get very familiar with it. You can see I still have the green buoys on the left and the red buoys on the right because it was important that I was able to get those people up out of the water in the helicopter in very little time. So what do I got? 126. So again, about 2, 3, 4 seconds slower than what we've ever had before. But maybe when we go do our mission, having the great helicopter makes the world a difference, right? So when we talk in the engineering design process about asking, this is a big part of it. We know that our mission is to save these people in the water and hopefully their ship. As importantly, we also need to think about what makes that successful. So we got to get to these people as quickly as possible so we can get them out of the water as quickly as possible. But whether that means the ship has to go fast or we need the best solution when we get to the shipwreck, because we don't have all the money in the world, 298, we got to make choices. And what you're going to find is that engineering the ship is really important. Engineering your solution is equally important. There's about 50% of the effort goes into finding the perfect ship design. The other 50% goes into really nailing what you need. Oh no, I'm drifting more. I'm talking too much. This hot air is making the ship go awry. But what you need to do to get the best score, how you need to execute the mission. So I don't see the shipwreck quite yet. Oh, I do now. I do. You're right in my crosshairs. You dark splotch on the horizon. So it's a shame that I don't know where the people are from this distance, because I could kind of set myself up to have like the perfect path to pick everyone up. But we are going to get in there. We're going to get close, and we will see. So looking at my time, again, it's going to take a little bit over 3 minutes to get out to the shipwreck. Uh, if we lost 4 seconds in the speed test, those that difference getting amplified, right? I've been having to go fast for a long time, and I'm not going as fast as I did last time. So now I'm taking 330. We'll see when we get to the cut screen, but this is quite a journey with the medium speed turbo engine. Does look like there's a bunch of people out here though. I don't like that. Yeah, look at that person way out there. That's not nice. Alright, so I can pick up these two people and maybe grab the others in one quick helicopter pass. But I want to come right down here and still get that ship. The one thing that you got to kind of keep an eye on is that uh, you want to make sure that you're rescuing the ship before you land. It can't be the last thing that you do. Alright, so I'm coming in on the left side of this guy. Oh, I'm going too slow. Really farmed it, botched it up a bit. So I don't want to run into him. I'm coming in slow. I'm saving the ship. I saved him. I saved him. Alright, so I'm taking off. And I'm saving him while I'm taking off. Oh no, I should have saved him. Let's see if it saves him for me. So I need to go out and grab this guy. Look at this 55 knots of speed. And it is saving him. Alright, so we're rescuing here. So it saved him. That means I just got one person. You can tell. I need the better glasses on. Where is this last person? 5 minutes already. That's all. Oh, it saved them for me. So we got everyone. I just had to go get that far person. Look at that. See, that's the frustrating thing, right? So if I would have had this helicopter on the last mission, better time. If I would have had the last engine on this mission, better time. But I still got a really great score. It's going to take a while to get up to this. Don't think that you're going to set this kind of score in this kind of time first try. Stay at it, though, and you can get there. All right? So this is our goal this week. Sunny, beautiful weather. Enjoy it. Search and rescue. Salvage the ship with the pump equipment. That's our red box. You need a green equipment to get access to the search and rescue mission. Bring a helicopter or a rescue boat to get there, and then try to figure out how to spend $2 million as best you can. I know $2 million just chump change to most of you all, but put it to good use. All right. Best of luck. Email us anytime. fleet@navalengineers.org, and we can give you a hand. Thanks a lot. Keep engineering.